some things here that you may or may not see in class, but x is a monomial, okay? But it's not because it's x, it's because it's got one term. Have you heard that before?
Yeah, I believe the X like has one in front of it, or it's just by
It's just
itself.
it's because there's just an x, okay?
Okay.
So for example, 7 is also a monomial.
Okay.
And if I put 5x cubed, this is also a monomial. So it has nothing to do with the power. It has to do with the number of terms. And these are each one term. Is that okay?
Well, wouldn't the 5x cubed be 2 since it has 5 and x?
So they're grouped together. When they're squeezed together like this, they are one term. They are one term. So here's what you're really asking me. Terms are separated by plus and minus.
Oh, okay.
Okay, and that leads us to, what is a binomial? Well, here's a binomial. X plus 1 is a binomial. Okay, because there are two terms. Okay. 7 plus x squared is also a binomial. Right. And again, like we could say 5x cubed plus 3x, this is also a binomial. And again, it's based on the number of terms. So it could be subtraction. It could be -1, minus x squared, minus 3x. It doesn't matter. Okay.
Okay.
Now, what do you think a trinomial is?
It would just be 3, like
Three,
3 of terms. Yeah.
three terms. So it could be like 1 plus 4x minus x squared. That's a trinomial. Could be minus 5x plus 7x squared minus 2. That's a trinomial. Okay. Now these all fall under the grouping of polynomial. Like they're all polynomials, but these are the more specific name. Okay. It's like your name is Joshua, Josh, my name is Matthew. We're all people, we're all humans. Okay. So they get into this, well, what's a polynomial? So generally after 3 terms, they go to polynomial. 1 plus x squared plus x cubed, that's a polynomial because there's 4 terms. But if it's 3 terms, you would say trinomial, 2 it's binomial, 1 it's monomial.
Mhm.
Right. So any questions on that before we move away from it a little bit?
No.
Okay. And again, I'm gonna send you a copy of these notes at the end. So if you don't get it down, I mean, I encourage you to take notes, but if you don't get it down, that's okay. You'll get it at the end. So greatest common factor. Okay. Greatest common factor. Any idea what that is referring to?
In here, my book, they want us prime numbers and composite numbers. So look through my book.
Oh, that's okay. You don't have to do that. I've just wondered where you're at on these. So I'm gonna start with an example here.
Mhm.
Let's say I have 2x plus 4y. Okay. And I'm going to tell you that this has a GCF of 2.
Okay.
Why do you think this has a GCF of 2 based on the numbers that are here?
2 times 2 is 4, and I guess 4 divided by 2 is 2.
Okay, so
Both would have 2.
here's another way to look at it. Are both 2 and 4 divisible by 2?
Yes.
Yes. Okay. So if we put a 2 on the outside here and we divide each of these by 2, can you tell me what would go inside parentheses?
X and 2y.
Plus 2y. Good. Now, if we were to distribute this 2 in, do you get back to the previous line? Is 2 times x 2x? Is 2 times 2y 4y?
Yes.
Yes, it is. All right, so let's look at another one here. Let's say it's 5x squared plus 10y squared. What do you think the GCF is in this problem? What is the largest number that goes into both 5 and 10?
5.
5. So your GCF is 5. So you put 5 on the outside of the parentheses, and you divide each of these by that 5. Can you tell me what would go inside parentheses?
2x and then 5y squared.
Okay, so x squared plus what goes here?
5y squared.
So 10 divided by 5 is 2y
Oh,
squared. 2y
my
squared.
bad. I thought we were like, for some reason my brain thinks minusing instead of
Okay.
dividing.
Yeah, so the fraction bar does mean division, and hopefully you'll see more of that in class. So for 2 examples, you might think, well, it's always just a smaller number, but that's not true. All right. So this is where we get into, slightly more difficult problems here. Let's say it's 9x plus 6y. Is there a number that goes evenly into both 9 and 6?
3.
3. Yes. Okay, so we've got 3 on the outside. You're going to divide both of these by 3. What goes on the inside?
3x
Plus.
2y.
Very good. Okay. Let's try another one here. Let's say it's 45x squared minus 25y squared. So looking at 25 and 45, what's the largest number that goes into both?
Say 5 again.
It is 5 again. Okay, now tell me what goes in parentheses, please.
9x squared and 5y2.
Y squared, good.
Y squared.
Good. All right, so GCFs, to kind of summarize what we've done so far, GCFs can either first be a number, or they can be a variable to a power. Okay, so we're going to go through the second one now. All right, so let's look at something. Let's look at, let's say it's 2x cubed minus 3x squared plus 5x. Do you agree that each of these terms has an x in it?
Yes.
What is the smallest exponent that you see? What's the smallest power of x?
5x.
Just the variable without the number.
5x or just x.
Just x. So x is the GCF here. Okay, and if you were to divide each of these by x, just want to see where you're at here. What would the result be? What happens when you divide each of these by x? And if you're not sure, we can go through that.
I guess I would guess a little like x squared, just x.
So
I don't really know.
That's okay. So for the first one here, it's x times x times x in the numerator over x. Do you see that one of those cancels in the top and the bottom?
Yes.
So that results in 2x squared. The middle one is 3x times x over x. Do you see that there is again a cancellation? So what does that become?
3x.
3x. And the last one here is 5x over x. What happens to the x's there?
They cancel.
They're gone. Yeah. So plus 5. Now, do you remember that there's really a 1 in each of these positions?
Yeah, I do.
What is 3 minus 1?
3.
Try again. 3
Or
minus
2.
1, 2.
2.
How about 2 minus 1?
1.
So do you see that you subtract the exponents to get the result down here? Okay, that's a little bit of a shortcut there. All right, let's look at another one here. let's say it's 9x to the 5th plus 4x cubed minus 5x squared. Okay. Is there a variable that's the same in all three of these?
No.
There's not an x in all three of them?
Oh, yes. There's
Okay.
X.
So for GCF, you're looking for either a number, like you look at all three numbers. This does not have a common factor here on these, but x does. What is the lowest degree exponent?
X squared.
X squared. So you're gonna write an x squared on the outside here, and you're gonna divide each of these by x squared. So I'd like you to try working this out and telling me what goes in parentheses down here below.
9x cubed.
Good.
4x. And then just 5x.
Well,
minus 5x. Or
so there's 2 minus 2 is 0.
mhm,
And if you were to show it out, x over x times x over x, if they cancel, cross out, what's left over?
nothing.
No, not nothing. It's a 1. Nothing would be
okay.
0. Is that okay?
Mhm.
All right. So now comes the synthesis. Okay, GCFs can be either a number, a variable, or both. Okay, so we're gonna look at some examples of both. So let's say it's 4x squared minus 16x. Okay, now just focus in on the numbers, just the numbers. What's the biggest number that goes into both 4 and 16?
Four.
Okay, very good. Now look at the two variables, x squared and x to the 1, which is the smallest degree exponent?
Just x1.
Just x, yeah. So here's what you're going to have to do. You have to divide each of these by 4x.
Okay.
So 4 divided by 4 is 1. What is x squared divided by x?
Uh, 1. That'd be
Four-
2 actually.
4
Well,
divided, 4 divided by 4 is 1.
1.
What is x squared divided by x? What did we do in the previous problems?
Trying to think.
Let's go back and look. How did we get a 3 here from 5 and 2?
We minused.
You subtracted. You said 5 minus 2 is 3. 3 minus 2 is 1. Okay, so let's go look at your new problem here. 2 minus 1 is,
1.
so this is x to the power of 1. Is that okay or not?
Mhm.
Yes, no, maybe.
It's fine, yeah.
Okay, now let's look at the next one here. 16 divided by 4. What is 16 divided by 4?
4.
Okay, and how about x divided by x?
1.
It's just
It's
1.
x.
Well, be careful there. You just said two different things. Is it 1 or is it x? Do the x's cancel, which make it 1, or does an x remain?
The x remains.
So let's go back up and look at a previous problem here. When you have the same number of x's in the top and bottom, what happens to those x's?
Cancel out and
They
they
cancel out.
become a 1.
Becomes a 1. So this is 4 times 1 if you want, but it's just 4.
Okay.
All right, let's try another one here. Let's say it's 25x squared minus 15x. So again, just focus on the numbers. What's the GCF between, what's the largest number that goes into both 25 and 15?
5.
5. So we're gonna put a 5 on the outside. Between x squared and x, what is the smallest power or the lowest exponent?
X.
X to the 1. Okay. So notice, and we've done this every time, we take what's outside the parentheses and we're dividing each of these by 5x or whatever it is that's outside parentheses. So help me out here. What is 25 divided by 5?
5.
Okay. And what is x squared divided by x?
1. Or just X.
Which is it?
X.
Yes, 5x minus what's 15 divided by 5?
3.
And then x divided by x?
1.
Okay, so just 5x minus 3. So this right here is your final answer.
Okay.
Now, what about this is unclear because I'm about to give you one to do on your own.
Mm-hmm.
Anything that's unclear about this?
No?
Okay, so let me have you try one on your own. So let's say I want you to factor 6x squared minus, let's go 4x. And I'm just looking for your final answer. So I want you to work this out and just tell me what your final answer is when you've got it.
Okay. The answer would be 3x and then 2 minus 2.
What is outside parentheses?
Oh, it would be 2x.
So here's what I was looking for. 2x parentheses, and what goes inside parentheses?
3x minus 2.
Yes, very good. Okay, so we're going to increase the difficulty just a tiny bit here. Let's say it's 12x cubed minus 6x squared plus 18x. So notice all I'm doing here is increasing the number of terms.
Mhm.
What is between the 12, the 6, and the 18? What is the GCF between 12, 6, and 18? What's the largest number that goes into all three?
2.
Okay, so it's actually larger than 2, but this is a good example for us to do. Let's just say it was 2. Okay,
Okay.
you wrote 6x cubed minus 3x squared plus 9x, and you looked at this and you said, boy, that's odd. So what if, and you say, oh, well, I think there's actually another number that goes into 6, 3, and 9, which is 3.
Mhm.
Do you agree with that?
Yeah, I just
Okay.
looked that over. Yeah.
Yeah, and so you realize, well, I think it's more than that. So you can actually bring the 3 out, and now it's 2x cubed minus x squared plus 3x. And the point is that if you don't know the GCF, or you get it partially right, you can then keep going. Like it's not like an all or nothing deal. Okay. But
Okay.
let's go back to the beginning, because it is best, just put this off to the side here. It is best if you get it all at once. So 6 is the GCF as the number. What about x?
Just X.
Just x, yeah. So you're going to divide each of these by 6x.
Okay.
Can you tell me what the result is inside parentheses?
2x2 squared minus 1.
Good.
And then plus 3, just 3.
Very good. Very, very good. Okay. So it's also possible, and we'll work this together here. It's actually possible for there to be more than one variable as a GCF. So let me show that here. Let's say it's 10x squared y plus 5x y squared plus 15x squared y squared. Okay. So between the three numbers, the 10, the 5, and the 15, what is the GCF?
5.
5. Okay. Now, if you just look at the x's, just the x's, x squared, x to the 1, and x squared, what is the smallest degree exponent?
X to the 1.
X to the 1. And do the same thing for the y's. You've got a y, a y squared, and a y squared. What's the smallest exponent?
Y to the 1.
Y to the 1. So your GCF can be more than just a single letter.
Okay.
So can you take an attempt at dividing these?
2x and then plus
Good.
1 y1
Okay. Keep going.
plus 3x and then y.
Good. Very good. Very, very good. All right. Okay, so we're going to actually stop right here.